Welcome, everyone. It's the Crypto Lark. Super excited to have back on the show Charles Hoskinson, the man behind Cardano. Charles, how's it going?
It's good to be here, Lark. Welcome to these interesting times.
Interesting times they are indeed. Now, we're going to be talking about a whole bunch of Cardano things today. We're going to be talking about Shelley and the testnet and Hydra and Ouroboros and a whole bunch of stuff. So for all the Cardano fans out there, this is going to be a juicy interview. So I'm really excited to have the chance. And we were saying just before we started rolling here, Charles, it's been a long time since we sat down. So I think we got a lot of stuff to cover. So let's go ahead and jump into it and start talking about Shelley. So what is likely to happen? What can we expect from the Shelley rollout?
hmm So the first time I talked to you, I think it was 2018, if I recall correctly. It was quite a bit of time ago, and at that point we actually had a parallel strategy. So there was an external firm that was building kind of a version of Shelley and Byron, like a vision of where we could have gone, and then we had another team that was working on the final version that we were intending on getting it to market by 2020. And what happened was that first team really just didn't get to the quality level that we felt comfortable with. And so we ultimately had to scrap that. And it was a really painful decision. And we said, all right, well, the primary strategy then is the secondary team that was building the final version of it. So the Shelley that's shipping this year very soon, like very soon, imminently, is basically the full thing, everything that we envision for the protocol. So all those research papers we wrote, more than 60, all the game theory we did at Oxford, all the ideas we had around how stake pools are going to operate and delegate and how to achieve certain security properties like adaptive security and partial synchrony and these things, that is what is shipping, that is what is Shelley. It's the biggest launch of Cardano's history. It's the most significant launch because it takes us from a static and federated system to a decentralized and open system. So basically an open participation. Anybody can run a stake pool and anybody can play. We've been launching it now for quite a while. We started in December of last year when we launched Incentivized Testnet. And what that was all about was basically just getting a certain set of actors who actually had the ability to run the system. And it was one of those field of dream things where we just hypothesized that if we built it, they would come. And it turned out they did. Over 1,200 stake pools registered, a few hundred are active, meaning they make blocks every single hour. And we developed a really great community around staking. The Telegram channel has thousands of people in it, and there's a big core of competency. And so then what we did is we sub-selected the top people there. We called them pioneers, and we just launched last week the Pioneer Testnet. And basically that is the training grounds to get everybody rolled over to what's going to be launching very soon for the public. And we're running them right now through a collection of exercises. I believe there's now 7 of them, and we have about 5 that we've finished. And each of those exercises are basically things like how to create a transaction, how to register a stake pool, how to rotate your KES, and all the other things that are required to actually run the network. So once we run through all of that, we'll open it up, have a open test net for the remainder of the stake pools to roll over from the Rust side. We plus the pioneers will train those stake pool operators to rotate from the Rust code to the Haskell code. And then basically it's just starting to turn on Shelley. So it's been a very long road. And I'm getting really old. I got the white hair and the beard. I got the man boobs now. And all that stuff is starting to wear down on me, but we're almost there. We're ready to go for the launch of Shelley. And it's really a beautiful product. I mean, it's built with formal methods. We have those beautiful specifications we've written. There's been literally thousands and thousands of engineering hours that have been put into it. And we wrote the whole thing in Haskell. And it's just a joy to see it all come together. But it's certainly a huge effort to go from a static federated system to a dynamic and decentralized open system.
And this is a major rollout for Cardano. And it's very exciting to really see it all starting to come together. And I know there's multiple stages for the Cardano rollout, and this isn't actually the end of the Cardano rollout, but this is just a major step. Like you said, we're getting away from the federated state of the network to actually really having this big, vibrant community of stakers. And I think it shows how much enthusiasm there is for Cardano in the Cardano community to see how many people have been participating in the staking test net.
Enormous, man. 19,000 validating nodes there and 1,200 registered pools. And that's a test net. It's really amazing to see how many people showed up. I mean, this is the equivalent of like Ripple saying we're going to change our consensus protocol and go from static and federated to dynamic and decentralized. No cryptocurrency has really done this at this scale after they've rolled out. It's important to understand Byron's been out now for over 2 years, and as a consequence, everybody's gotten used to an operating mode, and they've gotten used to the system behaving a certain way. And now we're just like saying it's a totally new system in terms of the way it operates. So everything had to be examined. We had to rewrite the way it gets listed on exchanges. So we created a Drestia and a GraphQL backend for that. And so there's all these amazing things there to make it easier to list. We had to completely redo the way it works with wallets. So Yoroi had to update, and Adalite and all these other guys in the ecosystem. And then obviously we had to train a group of people that could take over the consensus side. And then we had to figure out all the economic parameters. You know, how do you set the saturation parameters, desirability, the pledging mechanics, these types of things. We have these beautiful game theory models we constructed out of Oxford, but those are just that, models. And so they had to be compared to commercial realities. So you had to train up a group of business owners who run stake pools and then get them to provide feedback and set these parameters with the business owners. It's really been just a colossal effort, and we're almost done with it. And you mentioned that there are more phases. Yes, the first was the Byron reboot. So that was getting from the old crap code to the new amazing formal methods code that's beautiful. We did all of that in April. We did 8 releases or something like that in April, and it was just went without a hitch, and people love it. Restoration times are crazy good. Sync times are good. Daedalus is finally a great product we're very proud of. We got it to a point where it's very stable, and now we've been building on that foundation very diligently and systematically with the Pioneer testnet, then the Open Pioneer testnet, then the balance check, and then finally the launch of Shelley. But then after that, there's smart contract support and then voting systems and these things. But because it's such a good code base and it's so modular with its polyolithic architecture, it's very easy for us to roll things out rapidly. We're on a 2-week release cycle, and we're right now #1 for commits. If you go to Cardano updates, you can see we're the fastest, most committed cryptocurrency project in the space. We even beat Ethereum in terms of commit volume for our software.
Wow. Wow, that's always been really impressive, just how much work is going on behind the scenes with Cardano. And I think that, you know, when people, the critics, they look in and go, oh, but things aren't happening as fast as I want them to. I want my moon bags to go up faster. And it's a lot of technology you guys are building here. And what you've just described, building this incredible base layer, and now you've got this perfect launch pad for rolling out all the other features that you need for Cardano.
Yeah, and you know, it was a process to even have the discussion of what should that base layer look like. And at the same time, the Cardano Foundation has been working lockstep with us to figure out how do we actually roll out our CIP process. So when you want to upgrade Bitcoin, you use a BIP, a BIP. Ethereum, you use an IP, an EIP, and that allows you a decentralized way to propose updates to the system. Well, similarly, we need a Cardano improvement proposal. So we just launched that in May, and we've been working on improving it. And then we need a standards process as well. So CRCs, Cardano Request for Comments. So that's a whole parallel track that's working, along with the governance track that's working, along with the smart contract track that's working, along with Byron reboot turning into Shelley, and along with getting the exchanges on board with the new stuff. We're not sleeping much. It's like there's just so many moving pieces to all of this that have to just fit together perfectly. And so far, the orchestra is playing beautiful music, so I'm quite happy with it. But we're not out of the woods yet. The good news is that we kind of see the end. We kind of see how it all fits together and where we need to be. And we've gained the ability to be very systematic about it. So we don't regress. We don't have like what happened where we got blindsided when we realized that code base in 2018 was just not viable, and the things we planned for it and how it was going to evolve were just not going to work. We had to throw it all away and move to something else. We came to that conclusion only after a year of trying to resurrect it and get it to a sustainable state. Here, it's like all the things we'd written in the beginning of the year about what were going to happen when the reboot came out, the delta between reality and projection is very small. Like literally when we have delays, there are days or perhaps a week, but it's not 3 months to get a feature out or something like that. And you're really going to see that actually in just a few days. So I think we're recording this on May 25th. The 28th, we do the product update, and there's a lot to announce there, and even more to announce in that product update than the prior product update that we did in April. So there's acceleration in that velocity. It's exactly what you want to look for when you have a low technical debt architecture to work with.
Very, very exciting stuff. Now, I want to talk a little bit about Ouroboros, the consensus protocol that you guys are working on here for Cardano. What makes this so different from what other chains are building right now?
Well, the first thing that we started with when we started the Cardano project is we actually didn't know if proof of stake was going to work or not. We didn't know if proof of work was the end-all be-all, and you could never synthetically create proof of work. So the first thing that happened was we wrote a model called GKL, where we rigorously defined what is a blockchain and what makes it secure. And then what are all the security properties you get for proof of work? So then you have a target. And then the question is, can proof of stake ever emulate that or not? And it's a very controversial thing. If you talk to people from Blockstream or the Bitcoin side of the world, the maximalists, they say that proof of work is holy and nothing can compete with it. And they have all these strong arguments like nothing at stake and long range attacks and grinding attacks and so forth. So then the next part of the Ouroboros agenda, once we had a foundation, was to say, could we synthesize consensus that proof of work does in unrealistic assumptions, meaning like everything works perfectly and everybody's reasonable? Can we even achieve the same things? And that was the first version of Ouroboros, the Ouroboros Classic paper. So it's synchronous. You had public stake pools. It's all this stuff was not optimal, but because it worked, then we had a foundation that we could build on and keep adding new security features and eventually bring it into line so that we could replicate all the security and usability properties that proof of work has. So for example, partial synchrony. Not everybody's going to show up on time, so because it's a distributed system, so some nodes will be delayed and so forth. So we did that. Adaptive security. So we needed things like you don't know who won ahead of time. You only know after the fact, and you can prove that, so people can't sell their votes or a DDoS attack the next delegate or something like that. You need the ability to bootstrap from Genesis. So that's a property where when you join a proof of work system, you can know nothing. What you do is you just get history and you weigh it. You look at the algorithmic weight in each of those chains. You say, well, this one's the heaviest, so that's the longest chain. I'm going to go with that. So you never need a checkpoint. You can just bootstrap from the very beginning of the system and verify that. So we did that with Ouroboros Genesis. We achieved that property. So we've been systematically working our way through every security property that they have, and we create a whole family of papers. I think there's now 6 or 7 of them, and there's more on the way. And that's really what makes Ouroboros special, was that we started with from first principles, what is a blockchain? And we kind of worked our way through and said, what properties of Bitcoin do we really like? We'd like to replicate in terms of how it operates. But then at the same time, we'd like all the benefit of proof of stake. And that's things like very fast finality. You'd like low energy consumption. You can run the whole system on 10 kilowatts of power. The fact that you have endogenous security, you need security within the system, not endogenous security, exogenous security outside of the system, that puts you in a really good position to start optimizing around the stake pool model. So you can use them for layer 2 embedding, like you can add Lightning channels or Hydra channels or Oracle solutions. In addition to that, you can use them to accelerate the network stack. There's all these things you gain with the proof of stake side of the world in general. Also, the delegation model is really cool because it's a virtual resource. So if China was to ban mining tomorrow, super difficult for the people running mining pools there to get their miners out of China into Mongolia or some other place. When it's a virtual resource, you click a button, you can rehost your server from China to Switzerland or to Liechtenstein or to New Zealand at a click of a button. So you have a much more resilient system in that respect. So there's a huge amount of benefits that proof of stake has, from environmental to performance to sustainability to the ability to layer additional services on that you get for free when you're in that model. But then there's this huge security menu that you have to kind of worry about. And it took us years to work our way through to a point where we got confident enough that we had all those models. And finally, this is a business. When you're running consensus, it's a business, and Satoshi got it right, and that's why we have giant mining warehouses in Georgia and Norway and these other places. So similarly, if you build a business correctly, stake pools should be able to operate every day, make a profit, and still sustain the network without being super expensive and requiring us to print billions of dollars of value every year long term. So we had to figure out the business side of that as well. And that's what we've been doing with the pioneers, what we did with the incentivized testnet over the last 6 months, and what we've been doing with Oxford University and the papers we published there. We're trying to get the game theory right and the model tuning right. And that's been the single hardest thing for Ethereum too. They've been working on that for years as well. And it's not trivial by any sense of the word. So if I had to succinctly say, well, what is Ouroboros? I'd say it's a first principles based new way of doing consensus that keeps the stuff we've come to know and love from Bitcoin that's very useful and great, but then does it in a much more sustainable, energy friendly way that also allows you to layer on many more utilities than just mining to the system, and does so in a way that attracts lots of competition, lots of decentralization, and lots of businesses. Mining tends to centralize to a small group of actors because of economy of scale. The way we've designed the system over time, our hope is it gets more decentralized. So right now we're targeting 1,000 stake pools we could envision in the future 10,000 or 100,000 or something like that, and future iterations of the protocol, and different ways of measuring security above and beyond just ownership of the token, perhaps a proof of merit type of a system. So this is the beauty of Ouroboros, and it's all been done in the academic circle. We've had more than 10 universities be affiliated in the development of Ouroboros throughout its life cycle. These papers we write aren't just white papers, they're actually scientific papers, and they go through the peer review process just like the signatures go through, or any of their form of cryptography goes through. And the people who read those papers aren't cryptocurrency people. They're actual academic cryptographers and mathematicians and computer scientists at conferences that are 40 years old. And the conferences we submit them to, like Crypto and Eurocrypt and CCS, the acceptance rate is in some cases 10% or 15% of the papers submitted. But we got in consistently here, which meant we met the threshold of peer review and due diligence. So it's a very different thing than a normal consensus protocol. It's first a family of them, not just one. It's been built in a very first principles way, and it's been built with peer review and formal methods to try to tease out these things. And it's been built lockstep with the community to make sure that the game theory matches reality and that it ends up being a sustainable protocol. And we've validated that with the incentivized testnet and the Pioneer testnet.
Very, very interesting. It's this academic process of getting, everything checked and having these papers written up, and it's a time-consuming process, but it's a process that I believe, and I think a lot of Cardano supporters believe, in the end is really going to be a process that wins out in terms of what is finally delivered.
This is the single biggest misnomer, I think, about the process, is it ultimately is faster for certain types of research. So if you contrast Casper to what we've done, what's happened with Casper is they have this giant ball of stuff that they have to do, design requirements. And so they write a protocol and it works until it doesn't. They go back to the drawing board, write a protocol, it works until it doesn't. They go back to the drawing board. And that iterative hacker mentality, it just keeps going and going. And it's like, how long is a piece of string? And then eventually they're like, maybe we have something. And they've been working on this since 2014. So that's like 6 years of like constant effort. With the academic process, you divide and conquer. So you say, what are the fundamental problems that first and foremost we have to study and understand? So before you even build a consensus protocol, you have to have a good definition of what are you trying to reach consensus about. So that's what the blockchain formal definition is about. Then you say, okay, what security properties are important? And then you divide and conquer. You say, okay, well, I can't solve all those security properties in the first protocol design, so let me try to solve the most important ones. Then you systematically walk your way through adding more complexity to the protocol where necessary, like, for example, going from MPC way of generating random numbers to a VRF. Okay, so you do that and you get faster and you get more participation and you get adaptive security and all this other stuff, but then you have to come up with more elegant stuff for that. But every time you build a layer, the layers you're building on are already done. So you're laying a firm foundation. The other way, the Casper way that they've been doing through with ETH has been, well, it didn't work, throw it all out, let's start a new model. It didn't work, throw it all out, start a new model. And they just keep going and going until they finally find something they think works. But you have no security proofs. You have no guarantees that the foundations are solid. And then usually you have trade-offs that you don't really tell people that are pretty nasty. Like, for example, when you go to a sharded ledger solution like they have, you don't have 50% Byzantine resistance. You have a third to a quarter. So you lose security when you expand the system, and then you just say, well, that's the way it has to be. And so, well, that's not necessarily true because you didn't start from first principles. The other thing is you don't have a lingua franca. So when you go with this foundational approach to the scientific method, then every single researcher in the entire space who's thinking about those problems has read your paper, understands what you're trying to do, and then occasionally comes to you and says, there's a better way of doing things. If you look at Ouroboros itself, the first paper we wrote in the series, I think there's almost 800 citations on it, which means 800 other papers that are doing work related to our work have read and cited our paper, and in many cases interacted with our scientists. So instead of just a smaller team of researchers or a moderate-sized team of researchers working on it, you now have the entire totality of the industry, of the cryptography community, the distributed systems community, who are now thinking about these things. That's a huge benefit because I don't have to pay them. They're just working for free. They're providing these ideas for free. Recently, for example, Pramod Viswani out of University of Illinois Urbana-Champaign, just as an example of this, noticed there were some ways to optimize the approach we were doing proof of stake. And he created his own variant called Nakamoto proof of stake and published his own paper based on our work. So we wrote something and inspired a completely independent team at UIUC and Stanford to then write their own paper and produce their own ideas based on our ideas, inspired by our ideas, and go extend capabilities in a new dimension. And because we're all building on the same type of foundations, the things they've done, we potentially could easily plug into our system. So that's the point about sustainability of research. You have to build as a centralized brain. You cannot have a cult of personality around one team or one person, no matter how brilliant they are, because what happens when they die? What happens when they retire? What happens when they move on? You need to build a culture and an ethos that you're all talking the same language, and anybody anywhere in the world, no matter what university they're at, where they're at, can write a scientific paper, and they know that that idea can inspire or drag something in. We've even been inspiring some of the Ethereum community. For example, Parity Labs, Parity Tech has been writing papers on Ouroboros with variants. So they've changed some of the clock stuff, and they published their own Ouroboros paper that they're using in Parity substrate. So it gives you a sense of this cross-pollination that can occur when you have these good ideas. When you follow the approach Casper's followed, it's slower. They've been working on it longer, and they still haven't launched their product, whereas ours is imminent. And then also nobody can copy it until the very final thing is done, and they have to reverse engineer it and figure out how it works. And then also, in many cases, it's going to be incompatible with where the state of the scientific community is at. So if they wanted to adopt anything that came, like Avalanche or other things that are coming, they just can't integrate it in. It's not compatible. There's an impedance mismatch there. So it seems faster because you can get your first result faster. But when you actually are thinking about the long-term growth of the ecosystem and the long-term evolution of the ecosystem, you end up being substantially slower because you have to throw away lots of steps over and over again, whereas we get to keep all of them.
The long-term approach is actually something really, really interesting that I feel like so many short-term speculators completely forget about, that we're actually building systems here that hopefully are going to be around for a very, very long time. And to go back to an earlier point that you made, Bitcoin proof of work mining, right? Where's that going to be in 50 or 100 years? How much power will it consume? How much centralization will happen? We've already seen it become very, very centralized, with really it becoming a game of people who can put up 50 or $100 million to create giant mining farms. Those are the guys who are running the network nowadays, whereas over time, Cardano will become more decentralized as more and more people start staking within that network. So it's a very different approach, towards so many different things and taking that long-term vision. Now, one thing that I do want to make sure we hit on here is to talk about scalability, because this is obviously such a hot topic in the entire crypto community. It's sort of a, Johnson measuring contest when it comes down to it. How fast is your blockchain? How many transactions per second can you boot? But Hydra is a very, very interesting innovation that Cardano has brought out. So you tell us a little about what Hydra is and how that's working to scale Cardano.
Yeah, so first off, you have to talk about what is this thing you're scaling around. So the basic unit of interaction in these systems is generally a transaction. And then not all transactions are created equally. So a Bitcoin transaction is fundamentally different from the things that happen on Ethereum or Cardano. So general transactions have 5 properties. So usually they have an asset that you care about, something of value. So that's a token or the underlying currency of Bitcoin, an ADA, something like that. You're moving something. Then you have entities involved. And then you say, well, what types of transactions are allowed? One-to-one, one-to-many, many-to-one, many-to-many. There's different messaging patterns that you have there. So, for example, you could do 1,000 transactions one-to-one, or one transaction to 1,000 people, right? So it just depends on how you bunch and bundle these things. Then you have metadata. So metadata is saying, well, what's the story of the transaction? So what does the system talk about? It's going to keep a timestamp. Maybe it's going to have a bunch of context about geography. Where did this transaction happen? And that can be very important, by the way. Like if it was drawing $100 from an ATM, it's very different when you're doing it next to a restaurant versus doing it next to a brothel. Probably have same type of transaction, same type of value, but you're imagining, there's probably a different context of what you're doing with that. So it'd be really unfortunate if that was preserved forever. So there's a metadata component. Then there's contractual components. So you're thinking to yourself, well, what level of complexity, the spending policy that's in here, how many contingencies are here? Like, can I only send you money if I prove that I am a lawful, legitimate actor? So maybe there's a compliance layer like KYC and AML, or maybe you're only accepting money from certain geographies, like I only take money from America, but not from North Korea or something like that. So there can be all kinds of exotic spending policy that's embedded there. And then they all live in a regulatory regime. So you have to think, well, how do we handle that? Do we want to automate it, or is it off-chain? And then you have identities, like who are these people? So it's not just the pattern of how many you're sending it to. Is it Lark to Charles? Is it Lark to Microsoft? You know, these types of things you think about. So your system has to make opinions about all the things on chain that are going to be done for you. And if you do a lot of that on chain, that transaction that you're doing is a lot more sophisticated, takes a lot more time to validate, it's a lot larger in terms of its space than if you're only doing one of those things on chain, like Bitcoin. It doesn't have support for multi-asset. So the only thing you do is a push transaction between addresses with specific validation logic. So all that other stuff, the named actors, the metadata, you have to kind of extract it somehow outside of the system. So that's the first thing, is you have to put the goalposts down of what is a transaction. Then the next step is, well, how many of these things, once you've set the goalposts down, can you do per second? Okay, so then we say this much TPS or that much TPS. And then there's a question of value. So do you want the same settlement system for all transactions? So do you want the $5 billion transfer of value to be on the same settlement rails as the microtransaction that you do to tip a video that's less than a penny? Do they have the same economic priority? Do they share the same state space in the UTXO or the account space or something like that? So the point of Hydra is to take a slight opinion on this and say, okay, Cardano is a very powerful system. So it's significantly more stuff can go into the transaction than in Bitcoin. So we created a new model for this called the extended UTXO model. It allows us to have spending policies and multi-asset and smart contracts and all these things. And DSLs could even bring in regulatory dimensions. And embedding Prism in means we can put identity native on chain. So there's a lot of cool stuff there. And that's a very sophisticated transaction. And the base ledger can perform very high speed for these things because Ouroboros is a very efficient protocol. So you can potentially have hundreds of these things going on every second. But then when you start stratifying these transactions, you're going to notice that big pools of them are low value transactions. Big pools of them are occurring frequently, but collectively are only talking about maybe 5%, 10% of the total value of the ledger. So a lot of turnaround, but they're just bloat. So it makes more sense to batch those and put those into a different layer of the system and allow then for those things to enjoy acceleration. So you can do a lot more of them. The fees go down. They get instant finality instead of having to wait for probabilistic finality. And that's kind of the concept of Lightning. So what we did is we just took the ideas of Lightning and we said, can we have native smart contract support for this and build it so that you can have as many channels as you want and they can all communicate with each other, route with each other. And every time you add it, you get linear scaling. So what that means is you get X more TPS per second capacity instead of saying that it goes up and up and up and then it reaches an asymptote and just stays at a constant performance. One head, two heads, three heads, N heads, the system just keeps scaling. So potentially you could grow to the capacity of millions of transactions per second, long-term, years from now, decades from now, if you wanted to. And the great part about stake pools and delegation and all the things of Ouroboros is you have a very natural set of people to run this infrastructure. So as we start growing, you put these Hydra heads on top of stake pools, and then they have now two settlement channels. And so you can either settle on the main network or you can settle on the layer 2 network, and it's completely dependent upon your requirements. Is it the value very high or low? Do you care about the settlement speed? Do you want fast settlement speed or slow settlement speed? These types of things. And basically they just work together and it's a seamless user experience. It's all there. So Hydra took a long time to develop because it was one of our truly interdisciplinary papers. First off, we did it with our consensus team, but then we also did it with our programming language team because it wasn't good enough just to say you can put a transaction into the channel and it can do some things and then it comes out. We said you can put smart contracts with real state into these systems. They run and they do things. So the PL guys had to figure out how to do that and guarantee that things would be preserved and there wouldn't be rollbacks or other such things. So it was really a complicated effort, but we ended up doing it. It was one of the greatest collaborations we had with Manuel Chakravarty leading the PL effort, combined with Agalos and his team leading the consensus effort. But the end result is we have a beautiful base protocol. And we have a prototype team led by Rob Cohen, one of our product managers, and they're kind of exploring when we need this, how would we roll this out? How would we create a canonical design, almost like the bolt spec for Lightning? And then basically at some point Cardano can embrace it, and this becomes one dimension of scaling that we can achieve that's completely complementary to what Ethereum is doing, which is ledger-based scaling, which is a significantly harder thing. And it's not clear to me if they gain anything more by doing it in the way that these markets work right now. And it allows us to get a lot of that bloat that these systems tend to accumulate off-chain into different systems. The other really exciting thing about Hydra is you can make it interoperable with Lightning, and then you can actually start talking about cross-chain compatibility through that. So we talk about interoperability. And so you say, well, how do you move Bitcoin to Ether or Bitcoin to Cardano and back and forth? So when you could put a DEX in there, you could actually exchange in there. You can do all kinds of cool things once you have these layer 2 networks running. And basically just allows you now to start talking to other systems and talking in a way that there seems to be a standards-driven approach pushing through. Whether you love Lightning or hate it, it is an approach that Bitcoin is very aggressively pursuing. And it is an approach that is interoperable with Ethereum. So through this type of a system, once we get it all wired together, it'll be very easy for Cardano to talk to Ethereum and Bitcoin through those channels. So you can do more than just microtransactions and fast finality and high frequency stuff. You also will be able to do all of a sudden be able to communicate with other systems. So that's kind of the vision of Hydra, and it's a longer arc thing. It's not necessary right now. We're not even using 2-3% of the total capacity of what Ouroboros can provide. Most of these next generation proof of stake protocols are sufficiently performant that you're not saturating them yet. But it's a very easy way of adding scalability into the system without a hard fork, without a soft fork. It's just there. Plutus alone, extended UTX alone is enough to do it. We designed it with the PL guys to guarantee that. And we already have a set of people who are ready to go, the stake pool operators. And it's just an additional business line where they can make more profit. And because we built it with our accounting model, it's not just for ADA, it'll actually be for any user-issued asset on Cardano. When our multi-asset standard rolls out, you can take your token that you've issued on Cardano and run it through these channels. So suddenly you get fast finality and microtransactions and all of these other things basically added in when that's available. So it's going to be fun to do, and it probably will end up being done through a competitive process. So we might end up implementing a reference version, but then we'd love to see other developers in the ecosystem build their own variants, and they would collaborate around a specification. And then the stake pool operators and other people can decide to run their own channels wherever they want to. In fact, anybody can run a Hydra channel. You just have to put a pledge and basically lock some coins to secure that channel. So yeah, that's been one of our funnest pieces of research. It was kind of like the icing on the cake, or the the cookies you get to dip in the milk. Had to do a lot of work to get to a point where you could do something like that. But then this beautiful, elegant thing just kind of fell out, and it sits on top of everything, and it doesn't require mass disruption. If you look at the ETH2, not only are they changing a consensus protocol, they're going from a single shard space to a multi-shard space, and that requires traumatic disruption. You have to think of all these things. How are you going to manage time? How are you going to manage the manufacturing random numbers? You're going to have availability problems in the ledger, all this stuff that you would not get in a single shard environment that becomes exponentially more difficult to work your way around. And so you're putting a lot of implementation, execution, and ecosystem risk, so probably slower to market. Whereas this thing, whenever it's needed, you just put on top, and then suddenly we could technically process millions of transactions if we really wanted to. There was a path to that is very graceful, and it no way prevents us from pursuing the same approach that Ethereum is pursuing. And if we wanted to, we could do that, and we would organically grow to that. But it's probably not necessary. The base ledger probably could get up to about 1,000 transactions per second with these enhanced transactions we're talking about. There's a lot of questions of, is that even desirable? Like, there's a lot of network capacity issues there, and then you'd have to think of different ways to synchronize. So state space would have to be better managed, probably with snarks or things like that. So there's a lot of work to do if you want to get to that load. And that's for everybody. It's not just for us. And then there's philosophical questions like, do you wish to preserve inclusive accountability or not? You never hear this in the TPS conversation, but it's the hidden trade-off that everybody has to think about. So what is inclusive accountability? Basically, it's everybody checks each other's homework. This is what Satoshi promised when he created Bitcoin. He said, hey, here's Bitcoin, exclusively accountable. I can check it, you can check it. Nobody's special, meaning your check is just as good as my check. And we all do it, and that's what keeps the system secure. So every full node can regenerate the system, and every full node knows that the history they're looking at is valid according to the rules of the system. the problem is when you go to high performance systems, the systems just have too much going on for 99.99999% of users to be able to run a full node and validate it. So could you imagine what are the consequences of a 1,000 transaction per second system long term? Even if these transactions are modestly sized, you could imagine a blockchain that's in the petabytes or exabytes.
Mm-hmm.
Who can preserve that? No one. And so then there's too much network traffic as well. So who can keep up with the heartbeat of the network? Very few actors. So what means you centralize around a small group of people that preserve the whole system. So anytime you talk about scalability and how do we achieve high throughput, it's in the same breath you have to talk about, well, what are our principles? Do we wish to preserve inclusive accountability? Because the technology you need to do that is much more complicated and much more experimental than just the technology you need to achieve scale. So what we chose to do is say, let's keep it as simple as we can and have a beautiful single sharded high performance environment that can have that property of inclusive accountability for at least the next few years comfortably. And then let's add a system on top that slows down the rate of growth, but also gives us high performance. And that gives us the ability for the next 5-10 years to have a very comfortable growth window for performance. And then if the community chooses to invest in this technology, we could look at things like recursive snarks and other things to basically bring inclusive accountability in as a permanent feature, regardless of how big the system gets. We also need to do a lot of network innovation to make that happen.
It's certainly very exciting to see how that's moving forward. And it's just, yeah, I love that the incentives are built in for the operators to have an extra business model instead of needing to go and start an extra business, right? It's a very, very big difference between you can just do this also and get more money.
Yeah, and actually let's talk about that real quickly. So multi-asset, another thing we've been exploring, the multi-asset token policy, is can we have multiple native assets? So right now when you look at these systems, they tend to be layered. So you have Ether and then ERC20. And then ERC20 is a token class, but to fuel it, you need Ether to fuel it. Well, would it be cool if you could just pull that down and now your DAI is the same as Ether from the network's policy, which means that you can pay your transaction fees in your native currency if the stake pools can accept that. So when you're a stake pool operator, instead of just having one transaction fee set of revenue, the ADA transactions, all transactions that are occurring on the system, you potentially can make revenue and build an ETF of all the tokens that are running on that system. And that's really useful when you're talking about things like stable coins. If you look at the turnaround of Tether or any of these stable coins, there's many, 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 many more transactions occurring there than Bitcoin or Ether or these other things. And so I, as a stake pool operator, would love to validate all these things. We're also looking at potential things like Oracle infrastructure, these things where you can have that same idea. So you can federate it amongst those operators, and now they can run an Oracle business, and now they can run a DEX business and multi-asset business and all this stuff. So you have more revenue lines grow, and it's basically like blockchain as a service. So you all of a sudden have a much more vibrant, resilient business than just the volatility of one asset, whether that be ADA or something like that. And that's ultimately what you want, because then it'll drive more competition. More competition means there's more operators, higher quality amongst the operators, more performance amongst the operators, and so forth. And it's a race to benefit the consumer, as opposed to the systems we have now where they're optimizing around some arbitrary rule, which in many cases is not even beneficial to the ecosystem. And there's perverse incentives like greedy mining and things like that, or perverse incentives where they can collude and basically see things before the general network and see things to give themselves advantages and so forth that have been discovered throughout the years as scientists have looked at this.
One final question here for you for today. I feel like, Cardano and Ethereum, it's kind of like an Apple, Microsoft kind of, two titans of innovation and of industry working together here. Right now, though, we see, obviously, Ethereum has a very, very large network effect. Cardano, we're still going through these different developmental, obviously Ethereum is still going through developmental phases too, but how does Cardano catch up in terms of network effect to where Ethereum is?
Yeah, it's kind of like when Apple released the iPhone. They're like, how the hell did we get all these Windows developers into the Apple ecosystem? And Jobs like, you're asking the wrong question, man. If that is the game, we've already lost it, because they played that game for over 20 years trying to get people to develop for Mac OS versus Windows. And they could never get proportionality. They could never get traction at that scale. So you have to change the game to win the game. And that's basically what we're looking at here. First off, in terms of traction and developer set, if you break it down, you have functional, imperative, blockchain, non-blockchain. The slot that is largest is the imperative, object-oriented, non-blockchain people. Those are the Java developers, C++ developers, C developers, JavaScript developers, Python, .NET, all these things. There's 1,000 of them for every Solidity developer that exists. So the first lie that Consensus and these other guys push is that the game is over, Ethereum is the standard, they've already won, they have all the developers. By far, no. Nobody's won. These are early days. It's like saying Mosaic has won. There's only ever going to be one web browser. It's them because they have all the people, okay? It's not even close. The models have not been set. The paradigms have not been set. The standard development tools have not been set. And it's not clear how are we going to get those developers in. First off, as an industry, we should be thinking of Cordova instead of Internet Explorer. What Consensus and Ethereum are trying to do to the ecosystem, and it's so very damaging, is they're trying to lock people in. So they're building all this tooling and saying you're stuck on Ethereum. And that's exactly what Microsoft tried to do. They said ActiveX, lock people into Internet Explorer. So you write your stuff with our ecosystem and then you can't go to any of our competitors. We should instead be thinking of standards. The blockchain should be the back end, and that back end should be what you make a decision which best for your customers, and migration should be easy between one to another. Could you imagine saying that you can't move off Amazon and go to Rackspace or DigitalOcean? That would be crazy. No business would want to be in a model where they can't change their back end. And so we should be thinking of Cordova or Xamarin, these types of philosophies where you write once and it's easy to deploy on multiple blockchains. Then it's less of a question of developer adoption with respect of how do we get more Ethereum developers or Cardano developers. It's like, how do we get those imperative object-oriented non-blockchain people to adopt that framework that's cross-blockchain? And that'll bring tens of thousands, if not hundreds of thousands of developers into the ecosystem. Okay, so that's the first paradigm change that we have to get to, is stop trying platform-specific adoption and get to an industry-wide adoption and create a channel for those guys to get in. And Cordova is a great model for that, because that's how you write cell phone apps. You do it there, and suddenly you have an iOS app and an Android app with the same code base. Wow, it works great. Then you have to think like Steve Jobs and John Doerr in 2007 when they were saying, how do we get great people into the iPhone and make great experiences there? Those are your special forces. Those are the most elite developers. And you're not looking for 100,000 applications. You're looking for 50 to 100 really good, really sexy, great applications. They're going to really get people excited and drive heavy growth to your platform. So Jobs set up a $100 million fund with Kleiner Perkins specifically to do this and create a new paradigm, a new type of developer, and bring them in to the iPhone ecosystem. So similarly, that's what we're going to do, is create a fund and create an elite special group of people and bring them into Cardano to use Cardano-specific features. And we do that on the functional non-blockchain side. And we have a very native audience there, the Haskell community. We own that community. It's like all the guys who created the language happen to work for us. And we have great connections there. And we're basically saying you can take the stuff you've been doing since 1985 that you love and you are doing in industry right now for banks and enterprises and high assurance applications, and you can go and port all those skills and knowledge one for one to do it in our ecosystem. And by the way, we're the only ecosystem you can do that for. So paradoxically, you do the opposite strategy and you do both of these at the same time. You do the Xamarin Cordova blockchain for everybody and get all your imperative developers come in that way, and we'll have a channel for that. And then you get your special forces set up and get them dedicated funding. You really get them excited. And you get them to build beautiful experiences that are secure, they're relatively bug-free, and they do really cool things. And then what is the natural set of applications for that? DeFi. All these DeFi things that are being beta tested, not working so well and breaking all the time on Ethereum, you find better ways of doing those things. And because they have better tools and they're smarter people, they're more skilled developers, they'll be able to use those tools, that hindsight, to build the next wave of applications which have better user experiences, more reliability, more utility, and they can get great network effect. So both channels will bring tons of developers to our ecosystem and all ecosystems, and it's rising tides. As the industry grows, we all grow, and these systems all become great. Then you can do a proper comparison and say, well, why is it better to be on Cardano than Ethereum or EOS or Tezos? And there's going to be very real USPs to each ecosystem. And there's going to be real philosophical decisions that people make to each ecosystem, from control to privacy to resilience to on-chain versus off-chain governance, et cetera, et cetera. And we'd love to compete in that respect, just like Apple competes with Google with Android versus iOS. there's very real USPs on both these sides, and what you value as a architect. But the point is that both Apple and Google and Microsoft are still in business, and they're still gargantuan, and they still have massive network effects. So this is not a sub-zero game. It's not a situation for us to win that Ethereum has to die, EOS has to die, Tezos has to die. No, it's a situation where we can all grow to trillion-dollar ecosystems, just like Windows has and Android has and iOS has, and we just simply have different values, priorities, and experiences, and then people will aggregate naturally towards those and what they value the most. And there's clear philosophical differences already between the systems. So that's what we're going to do. We're going to have that imperative non-blockchain draw in, and we'll do that through a cross-blockchain approach, similar to what Cordova did for phones by analogy, because it's so powerful. And then we'll get our special forces with the functional side, and we'll use them to really build a beautiful DeFi portfolio there and make sure there's proper funding so they can get where they need to go. And both of those will be feedstock to really get our platform to the next level. And then once it's at the next level, we all can compete on equal ground. And it's important to understand that no standard has set. That's a lie when people say that. It's early days still.
Amazing, amazing stuff. Charles, thank you so much. This has been an amazing conversation. Just so much awesome information. So thank you so much for sitting down to have a chat with the community and let us know what is going on with Cardano. So thank you so much.
Yeah, it's been a lot of fun, Lark, and launch of Shelley's coming very soon. The virtual summit, we're probably going to announce that very soon too. So we'll have Rod get that to you, and we'd love to have you there. We're inviting a lot of people from the media to come. So it's going to be a virtual summit. So there's really easy to come. You just click a button, you join. There's going to be VR and all this stuff. It's going to be a big event.
Awesome. Well, I'll share more details of that with the community. So everyone out there, stay tuned. We'll let you know when that virtual summit's coming up. Charles, thank you so much.
It's been a lot of fun.